Alright, today we're going to be doing 9.7 and we're going to be talking about inverse trig functions. So we're going to want to remember our properties of inverse functions because that directly relates to inverse trig functions. Specifically, we're going to be looking at inverse sine, cosine, and tangent, including their domain and ranges, how this affects the evaluation and composition of trig functions and their inverses. Okay, so first let's go through a couple of questions. So one, in order for a function to have an inverse, what property must it have? Pause, think about it. Okay, so it's kind of a loaded question because there's a lot of properties it must have, but there's one particular one I'm looking for. So hopefully you've had a chance to kind of think a little bit. But what I was looking for was it needs to be 1 to 1. Okay, so we want to remember that that is a property that a function must have in order for its inverse to exist. So then the next question, well, what is our test to determine if a function has an inverse? So hopefully have a second, think about that, and that should be the horizontal line test. Why does this test work? Well, that test is determining is the function 1 to 1. So now think about the sine function. So picture the sine function in your head. Does the sine function pass this test? No. Okay, so then our next question becomes, so what did we do if a function was not 1 to 1? Do we just give up? That's always a valid option. In this case, though, we can move on. So what we did if a function was not 1 to 1 was we restricted the domain. So look at our sine curve here. How do you think it's best that we restrict the domain? Well, we want to restrict it so that it's 1 to 1 and so that it covers all of the values that sine covers. So how can we best restrict the domain so that it's 1 to 1 and still covers all of the values or all of the outputs that sine covers? Well, there's a couple of different ways in which you could maybe come up with this, but the way in which we want to do it here is we want to restrict it from negative pi halves to pi halves. So we're going to look at just this piece of the sine function. Notice now that that's going to cover the entire range of the sine function. So now with a restricted domain of negative pi halves, what is the range of y equals sine of x? Well, it's the same. It didn't change. So that's still going to be negative 1 to 1. Okay, well, do we remember how do we solve for a function's inverse algebraically? So again, think about that. See if you remember. We switch the x and y and solve for y. Well, if we do that, if we think about this equation, y equals sine of x, that would become x equals sine of y. Well, how do I solve for y? Remember, we can't just divide by sine because sine is attached to the y. So instead we use the arc or inverse function, and I end up with sine inverse of x equals y. The other way to write this, and we'll see this again in a minute, is arc sine of x equals y. So arc sine and sine inverse are the exact same thing, it's just two different ways to write it. Alright, next thing we want to remember, what is the relationship between the domain and range of a function and its inverse? And so this is incredibly important and it helps us graph inverses. They switch. So remember, the domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. So we'll see that when we look at the graphs here in a minute, but first let's look at cosine and tangent. So here, look at this is our cosine function. How should we restrict the domain so that the function is 1 to 1 and covers the entire range of cosine? So take a second and think about that, and then mark where you think it should be on the graph, and unpause when you're ready to check. So here we should restrict the domain to 0 to pi, including the 0 and including the pi. This covers the entire range of cosine, and it is 1 to 1. If we look at tangent, so again here, look at the function. How should you restrict the function so that it covers the entire range of tangent and is 1 to 1? So pause the video, mark where you think, and then unpause when you're ready to check. So here we'll restrict it from negative pi halves to pi halves, just like what we did with sine. However, now we do not include the negative pi halves and pi halves because those are asymptotes. Okay, so now here what I'm showing you is the actual arc sine or sine inverse function. So you can see that now the domain is from -1 to 1, and the range is from negative pi halves to pi halves, and it's included, the -1 and 1 are included, and the negative pi halves and pi halves are included. But this is the graph of the sine inverse function. So if you want, you can pause the video and copy that down. Now next I'll show you the cosine inverse function. So here's the cosine inverse function. So again, the domain is from -1 to 1, including -1 and 1, and the range now is from 0 to pi, because remember that was our restricted domain for the cosine function in order for it to have an inverse. So this is the cosine inverse function. And here is the tangent inverse function. So I've changed the scale of the graph a little bit just to show you that the domain of the tangent inverse function is -infinity to infinity, and the range is negative pi halves to pi halves, not including the negative pi halves and pi halves. Those are horizontal asymptotes now. Alright, so then our formal notation, inverse sine, cosine, and tangent function, y equals the sine inverse of x, or y equals the arcsine of x, y equals the cosine inverse of x, or y equals the arc cosine of x. Remember, those are the same thing. And y equals the tangent inverse of x, or y equals the arc tan of x, if and only if x equals the sine of y, x equals the cosine of y, or x equals the tangent of y. So these are formal ways to write the inverse functions. Alright, so then our definitions of the inverse trig functions. So y equals arcsine of x has a domain of -1 to 1, including -1 and 1, and a range of negative pi halves to pi halves, including negative pi halves and pi halves. The cosine, or the arc cosine, has the same domain, -1 to 1, including -1 and 1, and a range of 0 to pi, including 0 and including pi. The arctangent function has a domain of -infinity to infinity, and a range of negative pi halves to pi halves, not including the negative pi halves and pi halves. These domains and ranges you are going to want to know. You need to memorize and understand those, how they apply to the unit circle, how they're going to affect drawing triangles, and how they affect the graph. Alright, so now we'll see an example, or a few examples of how the domains and ranges affect evaluating or understanding problems involving arc and inverse trig functions. So here we have the tangent of theta equals 1, and we want to solve between 0 and 2 pi. We've done problems like this before. This is saying at what angle does tangent equal 1 between 0 and 2 pi, and we're actually going to have two answers. So where does tangent equal 1? Well, tangent is going to equal 1 when theta is pi fourths, and when theta is 5 pi fourths. Well, what if the problem said evaluate the arctangent of 1? It's actually asking the same exact question, but because the original problem has arctan in it, we're restricted to the domain and range of arctan. So this problem here on the left is saying at what angle does tangent equal 1 in between 0 and 2 pi. On the right, the question is saying at what angle does tangent equal 1 within the domain and range of the arctangent function. And actually, specifically what we're talking about is the range, because this value here is representing the domain. 1 is within the domain of tangent of the arctangent function because it's between -infinity and infinity. So our answer for what is the arctan of 1 is pi fourths. And that's why if you type in tangent inverse of 1 into your calculator, you're only going to get one answer. It's going to be pi fourths. So now I want you to answer the next two questions on the left. So cosine of theta equals negative 1/2 between 0 and 2 pi. Sine of theta equals negative root 3 over 2 between 0 and 2 pi. And then also evaluate the cosine inverse of negative 1/2 and the arc sine of negative root 3 over 2. So pause the video and unpause when you're ready to check your work. Okay, so for cosine of theta equals negative 1/2, we should get theta is 2 pi thirds and 4 pi thirds. But the cosine inverse of negative 1/2 is just 2 pi thirds, because 2 pi thirds is within the range of the cosine inverse function. 4 pi thirds is not. Sine of theta equals negative root 3 over 2. Theta is 4 pi thirds and 5 pi thirds. The arc sine of negative root 3 over 2 is negative pi thirds, because remember, our range for the sine inverse function is negative pi halves to pi halves. So negative pi thirds is a coterminal angle of 5 pi thirds, but 5 pi thirds is not within the range of the arc sine function, so our answer is negative pi thirds. This is the one and only correct answer. Now another thing, and I mentioned this a second ago, is before we even try to evaluate the arc functions, we want to make sure that this input value is within the domain of that particular arc function. If it's not, then we're done with the problem and there's no answer. Alright, so now what if we have the composition of these? So here I have I want to evaluate the secant of the arc tangent of negative root 3. So treat this just like we would the composition of other non-trig functions. So first figure out, well, what is the arctan of negative root 3. So negative root 3 is within my domain of the arctangent function. So now at what angle within the range of the arctan function does tangent equal negative root 3? Well, that's going to be at negative pi thirds. So now the question becomes, what is the secant of negative pi thirds? Well, negative pi thirds is the same as 5 pi thirds. The x value at 5 pi thirds is 1/2, so the reciprocal of that is 2. So our answer here is 2. So now I want you to try this one. So here we have the cosecant of the arctan of negative 5/12. So I want you to evaluate this. A hint is draw a triangle. So pause the video and unpause when you're ready to check your work. Okay, so first we want to draw a triangle with the information that we have the arctangent of negative 5/12. So since the arctan is negative, I know that it's going to be in the fourth quadrant, because arctan is only in the first or fourth quadrant because of the range. And then this is what my triangle is going to look like. It's going to be a right triangle. The opposite is negative 5, the adjacent is 12, so the hypotenuse is 13. Therefore the cosecant of this angle is negative 13/5. Alright, so now I want you to write theta as a function of x. So again, use our knowledge of triangles and trig functions. Pause the video, unpause when you're ready to check your work. Okay, so if I have this right triangle, I have the adjacent side and the hypotenuse, so I'm going to use cosine. So I know the cosine of theta equals 4 over x. Well, this is not an equation of theta as a function of x, so I want to solve for theta. So then this becomes theta equals arc cosine of 4 over x, or you could write cosine inverse of 4 over x. But now this is theta as a function of x. Alright, next one. Write an algebraic expression that is equivalent to the expression sine of the arctan of x. So again, draw a triangle, and basically what you're trying to do is you're trying to represent this as an algebraic expression, which means that it does not have any trig functions in it. Pause the video and unpause it when you're ready to check your work. Okay, so first we use the arctan of x to draw our triangle. So I draw a right triangle. It's a variable, so I'm just going to draw it in the first quadrant. Opposite is x, adjacent is 1, hypotenuse is the square root of x squared plus 1. Therefore the sine of this angle is going to be opposite over hypotenuse. Remember, we do not want to rationalize, we do not need to, and I don't want you to rationalize if it's variables. We need to rationalize if it's numbers, but not when it's variables. So in general, with these composition functions, whether this is a variable, a number, something on the unit circle, we first use the inside part, evaluate that, and then do the trig function of that information. So this might lead us to draw a triangle, it might lead us to find something on the unit circle. Alright, so our conclusion, inverse function always equals an angle, and then we want to make sure we know our domains and ranges of the inverse functions.